Hi all. In this tutorial, you'll be learning about how to set up the CFD simulation on a bicycle using the ANSYS Fluent teaching version. So we have two tires which are rotating in the clockwise direction if you look from this view, and whereas from this side, we have the same tire but they rotate in the anti-clockwise direction. So now we want to evaluate the aerodynamic performance of the bike frame, including the handles and the seat, and then we can optimize the design accordingly. So first we'll be starting with how to clean up the geometry for this model that we have in front of you. And then once the geometry is cleaned, we will be basically creating the rotating domain for both the tires. And then next we will move with the meshing, where we will be creating the domain before the meshing. And then we will apply some inflation layers only on the frame. And then we will create a tetragonal meshing. And then using the ANSYS Fluent, we will be assigning the right boundary conditions and running the transient model, turbulence model. So first we will understand how to open the workbench. So you all have to click on start button, and then you have to search for workbench. So you have to open workbench, whatever teaching version is installed on your PC. For me, it is 2023 R2. You all can click. So this window will open in front of you, which will be like this. And then first we will start with the geometry cleanup process. So this is what you will have when you open the workbench, ANSYS workbench. So first you have to go to component systems, and then you have to drag geometry. This is where you clean up your geometry and you create your virtual wind tunnel. And you just right click. You can see there are three softwares that can do this process, but we will go with a space claim because it is much more easier. So you all have to wait for some minutes, and then space claim will open, and then we can drag our geometry there, and then we can start the cleanup process. So this is how our space claim GUI looks like. So first we will drag our geometry, which is just by dragging it here. So this is how we basically easily import our geometry. So our geometry is in .step format, basically the CAD model. So you have to wait for some minutes in order to import your model. Now, on the left hand side, you will see your file name and different solids that are imported from your CAD software. So you can see we have so many solids here. This has happened because we have created this geometry from an assembly model. So now we need to simplify and we need to remove the things that will create problems when we are meshing, and then they will increase the computational cost because the number of elements will be increased. And so this is why we will clean up the model, because there are few things which will not influence the aerodynamic performance of the frame, like this chan and then this gears and this paddle. So we don't want these things. You can have, but you need to be expert in meshing. So we will remove this, which is caliper. Fork is very important. Front tire assembly, of course, this is important. Now we will remove this complete assembly because we don't need this. This is spin, which is very important, Control Z. Now we will remove this. We can remove this. No, that was important. And now we will remove this chain. We will remove this. We will remove all the bearings that we have. That's important. Frame is very important. Now we don't want this because we want to have a simplified CFD, and so we will have a simplified handle. Similarly, we will remove this. You can have this, but you need to create a very nice geometry where you have to clean up a lot of faces, which will uh, which will not create any problem with the meshing. So now let's see what is inside this. Okay, so this is seat. So we don't want too much complicated geometry for the seat. So we will remove this, we will remove this, we will remove this, we will remove most of the things. Okay, so let's see what's inside this solid. Upper surface is important. We will remove the lower surface. We don't want this. We don't want this. You can have the complete geometry, but it's again, if you get any meshing problem, then you need to use your expertise in meshing in order to resolve the problems. So this is the reason I'm removing the things that might create a problem. So we are removing some of the faces. We are removing these things because we want to have a rotation of our tires. So we can remove this. It will automatically become solid. So now we zoom in here. We delete this. We delete this. You just have to press the delete button in your keyboard to remove some of the faces. So now this is okay, and we will see what else we can delete. Okay, so we will remove these things. We will see where they are located in the assembly. Okay, so if we hide this, so it must be inside this. Okay, it is inside this assembly. So we will remove this. We will remove this. We will remove this. So now you can see we have both tires. And let's see if we can remove anything else. Yes, I think we can remove this. So delete this face, this face, this face, this face. Similarly, we can do here. Okay, so now we can use this fill feature to fill this face. So you can see it is very easy to fill the surface. Now it's solid again. And now if you zoom here, you can see a gap here. That means these two solids are different. So maybe we can pull this surface up so that it becomes one solid. So now we will only cut the solid, which is important. Control X, Control V. So you can see this is moving in the upper section. Now Control X, Control V. So we will only import the things which is important. And similarly, Control X, Control V. And okay, so Control X, Control V. Now we will remove. Okay, we haven't imported few things, which is the handle. So our bike handle is here. Okay, so this is also very important. Now I think we have imported most of the things. So now you can do the Control A and you can go to design and then combine. So this will automatically reduce the number of solids and combine them. Simplify your model. So you can see we have a tire tube different and then seat is different. This is not important. It's an inner solid. So now this is the bike frame. This is the tire. Okay, so it has splitted this surface, and this is the front tire. So now we will again simplify the CAD model. So we will hide. Okay, so what we can do is we can simplify this tire and keep the same geometry behind. So what we can do is we can delete back tire. We are doing this just for simplification purpose. Now we can hide this. We can hide this. Now we will remove these faces. We will have a very simplified tire geometry because these sticks will create a lot of meshing issues. So this is why we are removing this. And yeah, to make things very simple. Okay, so we have this as our tire. We can remove the strip which is in behind in at the center, and then we can fill these surface. So I can click on fill. I can select both the edges. Control and click on tick. So yes, your simplified tire geometry is ready. And okay, I think there is something which is missing. We can do the Control Z. Okay, so this was our model. We will remove this and we will try to do it again. We will remove this and now we will try to fill it. Okay, so this is our geometry. And now you can see our tire is tilted. It's not in the straight line. This is because the geometry that was provided was not appropriate. This is why it is happening. So we will try to rotate this wheel for a 3 degree. So you just have to click on this tire and then click on move and then rotate it for 2.5 degree and we will see, okay, it is approximately straight. Let's try 2. 2 is, I think, perfect. So 2 looks decent. Now we have this frame. Now the first thing that we will do is, you can see here, we have a very small gap between this face and this face. So what we can do is, we can move this tire a little bit so that our mesh do not interfere with any other solid. So we will remove this. So now we have enough gap between the cycle geometry, frame geometry, and we can bring it little down. This is I'm doing just to have a simplified CFD model. And now we can Control C and Control V. We can bring it back. Okay. So basically, when you do the CFD, you can basically extend this so that this is not interfering with any of the surface which belongs to your frame. Okay, so now we can think about how to create the domain. So now this is rear tire, this is front tire, this is solid for our frame, and then this is the seat geometry. Okay, So now we will create the interfaces. So in order to create the interface, we will first hide the. Okay, we can do one more thing. We can remove this face if we remove this tire for now. Okay, no, we have to do it separately. Okay, so this is our tire 1. We can hide the remaining things. And now we will go to sketch. We will click here. Now we will have the plane exactly normal to the center of this tire. Now we will try to create the interface. So you can draw this kind of a sketch, and then you can have, maybe you can remove this and then click on this 3-point arc. And now you can do it like this. Click on this, it will create a surface. Now we can revolve this surface to create a. So first we have to hide this, and now we click here, and then we rotate it. So our tire is basically this. Now we want to subtract our tire from this solid. So in order to subtract, you have to go to design, and then you have to click on combine. Before clicking on combine, you have to select the main solid, combine, and then this is the saw, and you have to click on your tire. So now press the escape button. Now this is basically this solid has your everything, every tire. Now we can remove this. So now if I hide this face, you can see your tire geometry inside. Same thing, we can do it for the rear tire. And also we need to see if everything is okay. So no faces are interfering with the inner faces of our frame. So same things we can do here. So maybe we can copy the same thing behind. So we can delete this and we can make a copy of this, Control C, Control V. Now we can click on move, and then we can move the same thing behind because these two tires are identical. But we have to make sure that things are not interfering. So in order to be on safe hand side, we can move this further back. Okay, just to make things simple. So now this is our frame, this is our seat, and okay, so now we can create the external domain. So in order to create the external domain, you have to basically click on prepare, and then click on enclosure. You have to click on whole geometry. So let's keep the inlet at 100 and this as 30 mm, the ground. Okay, so we want to have a non-symmetrical dimension. Let's make this as 100 mm, 100 mm, and basically this is ground, so we'll keep this as 50. 50. And then you can click on tick. So now this is our envelope. Control X. So first we have to press escape, Control X, Control V. Now this is another solid. We can remove this. So now if we hide everything, you can see we have the domain already, which is subtracted from the virtual internal domain. So now only three solids are important, these three. So we will suppress these things, suppress for physics, and we just need these two things. So these two zones will rotate using the sliding mesh, and then we have the domain outside. Okay, so now this is going to be inlet. We will create the name selection. So if you go on group, you can select this, click on create name selection, inlet. And now this is outlet. Okay, so now this is going to be your no slip wall. So for now, we will select all the faces as no slip wall. But typically, the bottom surface has to be no slip and other surface has to be slip wall. So we will name this as walls. So maybe we can hide everything. Hide. Okay, so now we will select the interface 1. Interface 1 underscore 1. Now we can hide this. We can select this, this, and this. 1 underscore 2. So now we can hide this. Okay, we can create the name for this interface. Interface 2 underscore 1. So in order to hide this, we can directly select all these three faces, right click and hide faces. Now we have three more faces. We can name this as interface 2 comma 2. Okay, so now we will hide the interfaces. Now you can see our simplified tire inside. So now everything else is going to be, these tires are going to be no slip walls. So in order to make them no slip, we have to select the right faces. So we can select the faces one by one. And we can name this as a tire wall. So now if we show all, and if we select all these things, And if we hide, so we can see only our bicycle frame. So this is bike frame. Better not to use any spacing when you are naming. So now everything is ready. We will be learning how to create the mesh. So you can see here we have a tick, that means our model is ready. You can go back and show all. Okay. So now we have to go to component system and we can drag our mesh. You can connect this with the mesh. You just have to drag it, right click and click on edit. And then you need to wait for some time. And then we will learn how to do the meshing. Okay, so your meshing will open. So you cannot see your geometry. It can be because by default, the mechanical is selected. So first what we can do is we can go back to our workbench. We can click on right click and click on update. Because if you see this power symbol, that means this will not load your geometry. If you click on right click and click on update, this will help us to create a mesh. So you just have to wait for some time and then our mesh will be generated here. You can see meshing completed, mesh is generated. We have still problem, so we can identify where we have the problem. If you go back to your mesh, okay, so this is your mesh. First we have to change it to CFD because we are creating the mesh for our fluid. So if you right click, click on generate, and let's see if everything is okay. And of course, this is a very big mesh. So basically you need to refine the mesh. And so in order to refine the mesh, there are several YouTube videos which you can learn how to refine the mesh, how to create the body of influence to capture the wake regions behind. And yeah, so everything is available online. So right now you can see our mesh is failed. It's happening because it's too big. So we will try to have zero point 0.1 meter base mesh size and we will try to generate it because there is so many curves inside. They required very refined mesh. So this is the reason our mesh is failing. So now we have refined our base mesh size and hopefully the mesh will be generated. Okay guys, so our mesh is generated. You can see we have a decent mesh, not too fine. We will remove these contact patches that was created by ANSYS by default, and you can see this is our geometry. And if I click here, you can see how the mesh is generated. You can see we have a very fine mesh near the tire region. It's happening because there are so many curves and then there is so many faces. So this is why mesh is very fine. And you can see when we have a very small domain, our mesh size is 8 million, approximately 8 million. So that means if we have a very big size, we will have So many elements. And if you don't simplify basically the geometry, we will have lot of elements. So now what we can do is you can learn on YouTube how to add the inflation layers on the bike frame, because you are going to study the coefficient of lift and drag for the bike frame. So this is why inflation layer is very important. In order to study, we have already created the name selection: inlet, outlet, wall, interface, 1, 2, 2, 1, 2, 2, tire wall, and bike frame. So now we will be learning how to set up the boundary conditions, basically the physics. So now we will move with the Fluent. So you can drag the Fluent here, and then you can connect mesh with the setup. After that, you have to click on updating the mesh. So once your mesh is updated, we will try opening the Fluent. Okay, so now our mesh is updated. You can right click on the setup, click on edit. So this dialog box will ask you how many parallel cores you want to use. So now we will stick with 10 number of cores, and we will always click on double precision, and then you start your model. So it will take some time to load the ANSYS Fluent, and then a window will open, and then the model will be imported, mainly the mesh and the boundary faces, and the number of parallel cores will be identified. After that, we will be setting up the CFD model. So before we start setting up the CFD model, we need to identify the center of mass for these sliding mesh domains. So in order to identify the center of mass, which will be used for rotation, you have to go to measure and then select this face, click on mass properties. So about this point, this object is going to rotate. You can just copy, and you can open the notepad, and you can just paste these coordinates. So this is for tire 1. Similarly, we will try to identify for the tire 2. So this is for tire 2. But these are in millimeters, so we need everything in meter. So yeah, please make sure that um, everything is okay. And also you have to keep in mind that we only need Z and Y coordinates. We don't want Y, because about Y axis it's going to rotate. So whatever Z and Y coordinates that we input, they are in meter, and we don't need X, because about X axis it's going to rotate. So now we will go back to our Fluent. We can click on transient, and we will not change we will keep it as a pressure based solver. And now we will give the fluid velocity inlet. So we will give it as 2 meter per second to keep things very simple for now. And then we will first try to create the meshing interfaces. So we have created these interfaces before. So this 1, 1 belongs to interface 1. Create. And this interface 2 is basically 2. So now we have established these interfaces. Now they can easily rotate by using this sliding mesh. Now the second thing that we have to do is basically the rotation. So right now you can see we have only one solid. We will see what that solid is if we click here, name, and then okay, so we need to create the name selection. So we can go back to here, and then we can see how many bodies we have, which is this. Now we will create the body name selection, which we forgot. So this is static. Static. Click on OK. Now we will hide this. So we cannot see our mesh. So first we will clear, we cannot see our geometry. So first we will clear our geometry. We will hide this, hide body. And then this is our rotor 1. Press the N button, rotor 1. And now this is our rotor 2 and rotor 2. So we forgot these things before. So now we will go back here. We will first try to update our mesh, and then we will update our setup so that we can see those solid surfaces inside our ANSYS mesh. ANSYS Fluent. Okay guys, so our mesh is updated. We will try to set up the Fluent model again. We will remove this, and then we will try to import the Fluent again. And we will try to import. Once again, we will try to update. We will wait for some time, and then we will open the Fluent. So our mesh is updated. Once again, we will open the Fluent now. So just right click and enter the number of cores that is available on your PC. So you need to wait for some time. The Fluent will open, and then the model will be imported, including the mesh and the names that we have created. Okay, so everything is imported. Now you can see we have 3 domains: rotor 1, rotor 2, and static. So first we will see if turbulence model is selected. So by default, SSTQ omega is selected, which is a very good turbulence capturing model. So then we will click on transient if you want to run this study as a transient. And after that, we will try to create the interface. So this is our interface 1. After that, you can give name as 2, click on create. So once this is created, now you can give the inlet velocity, maybe for now 1 meter per second. You can give the wind speed or your speed of the bike. For now, I'm just giving 1 meter per second. And then you can also give the RPM. So if you click on rotor 1, click on frame mesh motion because you are doing the sliding mesh in transient. So we go with the mesh motion. If you want to do the moving reference frame motion for the steady state simulation, you can use the frame motion. And so basically you can give the rotation axis as Z, and then this. Now we need to insert the Y and Z coordinates. So this is our rotor 1. So this is our so these were our coordinates that we were supposed to use. So now you can see we have to give this values. So our first value is minus 0.1608,526, 0.54, 504, 5333. And RPM you can, for now we can select it as maybe 2, and then we will again cross check if things are okay. Okay, so everything is fine. And then we can click on rotor 2. We can do the same process. Mesh motion absolute, we'll keep this as 1. 0 minus 0.1608,526 minus 0.4926667, and then I think it was 2. Then click on apply, close. So in order to see if everything is okay, we will go to mesh interface, and then we will see the mesh rotation, which is very important before you run the simulation, because otherwise if they don't rotate, then there is a big problem. So we will try to have interface 1, 2. So we will have these things. We will remove this display, and now we can click on preview mesh motion. Step size can be 0.01, maybe 100 time step. If they are moving and they remain static, they're not dancing in the space, that means everything is set up correctly. So we have given the name, and you can see after some time step, if they are coming out or they are moving in separate direction, that means sliding mesh code settings are wrong. So at time step 2, they are still in the same position. Okay. Okay, so that means they are still there. Okay, so everything is fine. You can enter the reference value. You can click on inlet. You can give the reference area because this is what will be used to estimate the lift and drag. You can click on rotor 1, and then you can go to solutions. You can go to definitions, force, and drag values. You can click on, you can give it a name of CD. Bike frame, you want to study the drag force or drag coefficient, whatever you want, you can study. Click on print to console. Go to your initialization. This is how you initialize. And then you can enter a very small time step. Then after that, you have to click on calculate, and then the calculation will start slowly. And you will see residuals and the coefficient of drag, the reports that you want to generate. So this was very simplified ANSYS Fluent tutorial related to CFD simulation of a bicycle. Hope you have learned something. Thank you so much for watching. We will wait for some time until we see some results, because we have 8 million elements, so this is why it is taking too much time. So I think it would be better if I can set up the steady state simulation. So you can go to steady state, and then we can go to here, and then we can copy to mesh motion. Click on apply. Same thing we can do for rotor 2. So you can see we are copying the coordinates. Now we can click on initialize. Okay, we will see again if we have everything set up for the steady state simulation. We can go here, steady state, and we can see if things are okay, everything is fine. We can go to initialize, go to run calculation. Number of iteration, let it be 1000, and then click on OK. Okay, so our residual is going down. That means our simulation is running, and we are trying to get the coefficient of drag. Similarly, you can get the lip force, drag force. You can study the parameters that you want. And with this, I hope you have understood how to set up the CFD simulation of a bike using ANSYS Fluent. With this, I'm ending this video. Thank you so much for watching it.